Hello, and thank you for reaching out and asking this question. Let's go through all three parts of this question. Before we get started, I do want to point out that the main point of this problem is to be able to distinguish between a combination and a permutation. What combinations and permutations have in common is that they both are dealing with distinct items. In our case, the items will be the qualified candidates. What they also have in common is that no item can be chosen more than once. But what is different between a combination and a permutation is that in a combination, order does not matter. On the other hand, in a permutation, order does matter. Of course, they have different formulas because of this. If I have n items and I'm trying to permute r of them, I would do n factorial divided by n minus r factorial. Versus, on the other hand, if I had n items and I was trying to combine r of them, I would do n factorial divided by n minus r factorial with another r factorial in the denominator. Okay, so now that we have those two definitions out of the way, let's go look at our problem using. So in part A, how many different ways can 4 officers be appointed? So we're talking about appointing 4 officers to the president, CEO, chief operating officer, and CFO position. So as we start with these 14 qualified candidates, does it matter which order we pick them in as we determine these officers? Yes, because the first person I pick would be president, second person CEO, so on and so forth. They're different titles, right? So part A is dealing with a permutation. I know you got this right, but I just want to go ahead and walk through this so we can make sure we see the difference between those two. So we're taking 14 qualified candidates and we are permuting 4 of them. We're looking at 14 factorial over 14 minus 4 factorial, which is 14 factorial over 10 factorial, which basically just breaks down to be 14 times 13 times 12 times 11, which gives your correct answer of 24,024. Another way to think about that is that there was 14 ways to choose the president, but then you can also choose the president to be the CEO, so then there's 13 ways to choose the CEO, but you can also choose those first 2 people to be the COO, so on and so forth. So each time you go, you're losing one possibility. Now let's look at part B. Part B is asking us how many ways can a committee of 5 be appointed. So here we're appointing a planning committee with 5 members. The officers can also serve on the committee. So we're still dealing with 14 qualified candidates. Now, but when I form this committee, does it matter what order I pick them in? No, because it doesn't say the committee has certain titles or certain categories of which these people are going to fall in. They're all going to be sitting on the same committee. So part B is not asking for a permutation, it's asking for a combination. So we're taking 14 items and we want to combine, make a group of 5 of them. So I'm now going to be using this formula here where I have 14 factorial divided by 14 minus 5 factorial multiplied by 5 factorial in the denominator. So this is 14 factorial over 9 factorial multiplied by 5 factorial. I would start writing this out as 14 times 13 times 12 times 11 times 10 times 9. And I would stop at the 9 and just leave that as a factorial. And I did that on purpose just so I can cancel out these 9 factorial. So that would then in my calculator do everything in the numerator divided by 5 factorial, which is 120 in the denominator and 240,240 in the numerator. And when I punch that into my calculator, I get 2002, which is where they're getting this answer from here. Now, finally, on to part C. What is the probability of randomly selecting the committee members and getting the 5 youngest of the qualified candidates? So if you pick the 5 youngest, there's only one way to do that. You have to pick the 5 youngest people. So there's only one way you could possibly do that. And how many possible outcomes are there? Well, how many ways are there to select the committee? 2002. If you have any follow-up questions, please let me know. I'm happy to hop on Zoom with you and go over this in any more detail. just let me know.